You miserable son of a bitch. I gave you my heart, I gave you my soul, I gave you my body, and you just threw me aside like I was some piece of garbage.
Yeah, my bad.
When people first heard that something in Florida was killing snakes from the inside out, the reaction online was almost universal laughter. Comment sections filled up with jokes. People pictured a B-movie plot, some kind of swamp horror flick where scientists in lab coats stand around a tank of wriggling parasites, congratulating themselves on a plan that is obviously going to go wrong. The story sounded too strange to be real. A living creature, smaller than a pencil, capable of working its way into the lungs of one of the most feared invasive predators on the continent and killing it from within. Surely this was internet folklore, the kind of thing that gets typed into a search bar at 2 in the morning and forgotten by sunrise. But the strange part is that it is real, and the truth behind it is far stranger and far more consequential than the jokes ever gave it credit for. To understand why a parasite became the unlikely centerpiece of one of the most important wildlife stories in America, you have to go back to where this entire saga started, decades before anyone had heard the word snake lungwort. The story begins with the Burmese python, a snake native to the swamps, grasslands, and forests of Southeast Asia. In its home range, the Burmese python is simply part of the ecosystem, a large constrictor that keeps rodent and small mammal populations in check, hunted in turn by larger predators and kept in balance by millions of years of coevolution. But somewhere along the way, the exotic pet trade discovered that Burmese pythons make for dramatic, impressive, photogenic pets. Hatchlings are small enough to fit in a showbox, docile enough to handle, and cheap enough that almost anyone could buy one on a whim. What buyers often failed to grasp was that these hatchlings do not stay small. A python that starts life at under 2 feet long can grow to 16, 18, even 20 feet, weighing well over 100 pounds, requiring an enclosure the size of a small room and a diet that most households simply cannot sustain. By the 1980s, South Florida had become one of the epicenters of the exotic reptile trade in the United States, and Miami in particular became home to thousands of pet pythons. It did not take long for reality to catch up with novelty. Owners who once proudly showed off their snake on Instagram-worthy photos suddenly found themselves overwhelmed by an animal that needed a walk-in freezer full of rabbits and could crush a grown man's arm. Some pythons escaped. Others were deliberately released into the wetlands surrounding the Everglades, dumped by owners who no longer wanted the responsibility. Then, in August of 1992, Hurricane Andrew tore through South Florida with catastrophic force, flattening homes, businesses, and, as it turned out, at least one python breeding facility near the edge of the Everglades. In the chaos of the storm, an unknown number of captive pythons were released directly into one of the most productive wetland ecosystems on the planet. What happened next was, in hindsight, almost inevitable. The Everglades offered everything a Burmese python could want: warm temperatures, abundant prey, dense cover, and critically, no natural predators large enough or numerous enough to keep the population in check. Female pythons can lay between 50 and 100 eggs in a single clutch, and with no evolutionary pressure holding them back, the population exploded. Scientists estimate that tens of thousands of pythons now inhabit the Greater Everglades ecosystem, a sprawling area of roughly 7,800 square miles, and the true number may be far higher, because pythons are famously difficult to detect. Their mottled brown and tan skin blends seamlessly into the marsh grass and cypress shadows, and researchers have long joked that if you can see a python in the wild, it is because the python has already decided to let you. The consequences for native wildlife have been nothing short of catastrophic. Multiple long-term studies conducted across the python's range in the Everglades documented a staggering collapse in mammal populations coinciding with the snake's spread. Raccoon sightings dropped by more than 99%. Opossum populations fell by nearly the same amount. Bobcats declined by roughly 8 to 7%, and marsh rabbits, cottontail rabbits, and foxes effectively vanished from areas where pythons had become established. Researchers who fitted rabbits with radio transmitters and released them back into python territory found that more than 3/4 of the rabbits that died within a year were killed by pythons. Wading birds, deer, and even alligators have turned up as prey. In one particularly jaw-dropping case, biologists found a 115-pound python that had swallowed a 77-pound deer, meaning the snake had consumed prey equal to 70% of its own body weight. These are not isolated horror stories. They are data points in a broader collapse of the Everglades food web, one that threatens the very predators, like the endangered Florida panther, that depend on the same prey base pythons are wiping out. Faced with a crisis of this scale, the state of Florida did what any government facing an ecological emergency does. It tried nearly everything. The South Florida Water Management District and the Florida Fish and Wildlife Conservation Commission launched organized removal programs, paying contractors to hunt pythons on public lands. The now famous Florida Python Challenge turned python hunting into an annual public event, drawing hundreds of participants, from seasoned wildlife professionals to enthusiastic amateurs armed with headlamps and snake hooks, all competing for cash prizes and bragging rights. Scientists deployed detector dogs trained to sniff out python scent trails through dense marsh. Researchers experimented with thermal imaging drones to spot pythons basking at night. One of the most ingenious tactics to emerge was the so-called Judas snake or scout snake program, in which biologists surgically implant radio transmitters into male pythons and release them back into the wild during mating season. Because male pythons instinctively seek out the largest, most reproductively active females, tracking a single tag male can lead researchers directly to a breeding female, sometimes accompanied by several other males in the same pursuit. Removing that one reproductive female can prevent dozens, sometimes over 100, future eggs from ever hatching. The Conservancy of Southwest Florida has used this method to prevent more than 20,000 python eggs from hatching, an achievement that sounds enormous until you consider it against a population that may number in the tens of thousands and continues to expand its range northward, with confirmed sightings as far as Lake Okeechobee. And yet, despite drones, dogs, bounty hunters, and radio-tagged decoy snakes, none of these programs were the origin of the strange, unsettling story that made headlines and, eventually, made people laugh before it stunned them. That distinction belongs to something far smaller and far less deliberate, a parasite that nobody released on purpose, one that simply came along for the ride. Its scientific name is Railiatella orientalis, though most people who encounter it simply call it snake lungworm. Despite the name, it is not technically a worm at all. It belongs to a strange, ancient group of parasites called pentostomes, organisms so evolutionarily bizarre that scientists spent decades arguing over whether to classify them as a type of crustacean or something else entirely. Genetic studies eventually settled the debate. Pentostomes are, in fact, highly modified crustaceans, distant relatives of crabs and shrimp that abandoned life in open water millions of years ago in favor of a parasitic existence inside the lungs of reptiles. Under a microscope, they resemble pale, segmented worms, vaguely reminiscent of a bean sprout, equipped with small hooks that allow them to anchor themselves inside the delicate lung tissue of their host. Railiatella orientalis is native to Southeast Asia, which means it evolved alongside Burmese pythons for millions of years, just as the python itself did before arriving in Florida. Over that long evolutionary relationship, Burmese pythons developed a degree of tolerance for the parasite. Their large lungs and robust immune systems mean an infection, while not harmless, is rarely fatal on its own. But when the same parasite arrived in Florida, almost certainly inside the lungs of the same released and escaped pythons that started the invasion, it did not stay confined to its original host. The parasite's life cycle involved an intermediate host, typically a cockroach or other insect, which consumes the egg shed in an infected snake's feces. When a smaller reptile or amphibian, or another snake, eats that infected insect, the parasite's larvae are released and immediately migrate to the lungs, where they mature, feed on blood, and begin causing tissue damage. In other words, once the parasite escaped its original host, it needed only for a native Florida snake to eat the wrong cockroach or lizard to become infected itself. That is precisely what happened. In 2012, a wildlife ecologist named Melissa Miller, working with the University of Florida, discovered the first known case of a native Florida snake infected with Railiatiella orientalis, an eastern garter snake found in the southern part of the state. It was an alarming discovery because, unlike the python, native Florida snakes had no evolutionary history with this parasite whatsoever. They had never developed any resistance to it, any tolerance, any defense mechanism at all. To a garter snake, a black racer, or a dusky pygmy rattlesnake, an infection of Railiatiella orientalis is not a manageable nuisance. It is often a death sentence. The disease this parasite causes is as gruesome as it sounds. Because many native Florida snake species are far smaller than the pythons the parasite evolved alongside, their lungs are proportionally tiny, and even a modest number of parasites can overwhelm the organ entirely. The dusky pygmy rattlesnake, one of the smallest venomous snakes in Florida, growing to only 15 to 24 inches long, has been hit especially hard because its lungs simply cannot accommodate the parasite load that a 12-foot python shrugs off. Infected snakes struggle to breathe. They become anemic as the parasites feed on blood within the lung tissue. In advanced cases, researchers and photographers have documented the almost horror movie image of the pale, worm-like parasite protruding directly from an infected snake's mouth, having grown so numerous inside the lung that there is simply no more room. Since that first 2012 discovery, the parasite has been documented in at least 19 of Florida's 4 to 6 native snake species, and it has spread to at least 34 of Florida's 6 to 7 counties, moving well beyond the Everglades and into the broader landscape of the state. This is the part of the story where the phrase "everyone laughs" starts to make a strange kind of sense, and also where it starts to fall apart. Online, the framing that spread fastest was that Florida had deliberately released a swarm of snake-killing creatures as a clever counterattack against the python invasion, a kind of biological special ops mission dreamed up by wildlife officials. It is easy to see why that version of events caught fire. It has a tidy narrative arc. The invader gets a taste of its own medicine, poetic justice delivered by a microscopic assassin. It practically writes itself as a headline. But it is not actually what happened, and understanding the real version of events is what makes this story stunning rather than simply satisfying. Florida did not manufacture, breed, or intentionally release Railiatiella orientalis anywhere. Nobody at a state agency stood in a lab and unveiled a plan to unleash pentastome parasites into the Everglades. The parasite's arrival in Florida is, instead, a textbook example of what ecologists call a co-invasion, in which an invasive species brings along its own hidden hitchhikers, and those hitchhikers can sometimes become just as disruptive, or more disruptive, than the invader that carried them. This distinction matters enormously, because it reframes the entire story. This is not a triumphant tale of clever pest control. It is a cautionary tale about how deeply interconnected ecosystems are, and how a single decision, whether it was a hurricane destroying a breeding facility or a bored pet owner opening a car door in the Everglades decades ago, can trigger consequences that ripple outward for generations, consequences nobody intended and nobody can fully control. And here's where the truth becomes genuinely stunning, in ways that go beyond the simple mislabeling of the story. Researchers studying the spread of Railiatiella orientalis have found something deeply counterintuitive. The parasite is not actually solving Florida's python problem. Burmese pythons, remember, evolve alongside this parasite and largely tolerate it. The overwhelming majority of the damage is being inflicted not on the invasive predator everyone wants gone, but on the native snakes that Florida is desperately trying to protect. In effect, the very crisis that many hoped might contain itself has produced a second, quieter crisis, one where beloved and ecologically important native species, snakes that control rodent populations and serve as prey for hawks, herons, and other native predators, are dying from a disease that arrived because of the python invasion in the first place, while the pythons themselves largely carry on unaffected. Scientists like Jim Wellahan, a veterinarian and researcher involved in studying the disease's spread, describe this as a textbook example of what happens when an ecosystem is exposed to a pathogen it never evolved alongside. When native species and native parasites coexist over long stretches of evolutionary time, a kind of biological détente tends to emerge. Hosts develop partial resistance, Parasites moderate their own lethality because killing a host too quickly is, from the parasite's perspective, counterproductive. But when a pathogen jumps into an entirely new, naive population, none of those evolutionary safeguards exist yet. The results can be sudden, severe, and very difficult to predict. It is the same underlying principle that has driven some of the most devastating wildlife disease outbreaks in modern history. From chytrid fungus collapsing amphibian populations around the globe to white nose syndrome devastating North American bats. Snake lungworm in Florida is simply the latest chapter, playing out in real time, in the same wetlands already reeling from the pythons that carried it there. There is, however, a genuinely fascinating and slightly more hopeful thread running through this story. Not every native species is faring equally badly. Melissa Miller's ongoing research has found that while several snake species show clear population declines associated with the parasite, one heavily infected species, the Florida cottonmouth, does not appear to be declining at the same rate, despite carrying substantial parasite loads. Preliminary findings suggest cottonmouths may possess some degree of natural resilience, whether through immune response, body size, or some other biological factor scientists are still working to understand. If researchers can pin down exactly why cottonmouths seem to tolerate the infection better than dusky pygmy rattlesnakes or eastern garter snakes, that knowledge could eventually inform conservation strategies, perhaps even future efforts to protect the most vulnerable species. Though researchers are candid that a large-scale medical intervention, capturing and treating wild snakes across the state, simply is not realistic. As one researcher put it, you cannot go out, catch every snake in an ecosystem, treat them individually, and then also treat every frog, lizard, and cockroach that might carry the parasite between hosts. Nature does not offer a shortcut that's convenient. So where does that leave Florida's python problem itself, the crisis that started this entire chain of events? The parasite story, it turns out, is really a subplot inside a much larger, ongoing battle, one that has actually seen genuine, measurable progress in recent years, just not from a parasite. In 2025, Florida's organized removal programs posted their most successful year yet, with python hunters removing more than 2,700 invasive Burmese pythons in just the first 8 months of the year, already approaching the entire annual total from the year before. Officials credit a combination of factors: increased funding, better trained detection dog teams, refinements to the Scout Snake program, and a public-private partnership that has improved compensation for python hunters while also creating a market for python leather goods, including boots, wallets, and even footballs made from removed snakes, turning what was once pure ecological damage control into something approaching a sustainable, if strange, industry. Since these organized programs began, they have collectively removed more than 17,000 pythons from Florida's ecosystems, alongside independent hunters who, working without state support for decades before these programs existed, killed hundreds more on their own. None of this means the python crisis is anywhere close to solved. Researchers are candid that even removing thousands of snakes a year barely dents a wild population that may number anywhere from tens of thousands to potentially over 100,000 individuals spread across a habitat larger than the state of Delaware. Complete eradication is, by most scientific accounts, no longer realistic. The more honest and more sobering goal now is long-term suppression, an ongoing effort to keep python numbers low enough that native ecosystems have a fighting chance to recover, rather than any fantasy of returning the Everglades to a pre-invasion state.